Now, talking about Boyle's law. The inverse relationship between the pressure and volume of a gas is known as Boyle's law. So when we have changes that occur, they occur in opposite directions. When a volume increases, that means that the pressure is going to decrease, provided that the temperature and the moles of the gas remain constant, because we can only change one thing at a time to do pure calculations. So our learning goal for this video is to use the pressure-volume relationship, otherwise known as Boyle's law, to determine the final pressure or volume when the temperature and the amount of gas are constant. So looking at a picture of what this is going to look like, Boyle's law states that the pressure of a gas is inversely related to the volume when, again, temperature is constant. So the product, P times V, is constant when the temperature and the amount of gas are held constant. If the volume decreases, then that means, because it's inverse, that the pressure is going to increase. So your equation that we're going to be working with is P1 V1 equals P2 V2. So here is a picture of a piston driving down some gases. So in the first one, we have a volume of 4 liters, and the pressure is 1 atmosphere. Or in the second one, when we compress it, we're going to be decreasing the volume to 2 liters. Therefore, the pressure is going to increase, because it's inversely related, to 2 atmospheres. So with Boyle's law, PV equals a constant. So the amount of pressure times volume is a constant, provided again that the temperature and the amount of gas remains the same. So if we do a little bit of examples here, P1 times V1 equals 8 atmospheres times 2 liters. That would give us 16 liters, atmospheric liters. And then again, if we're going to change these, right, if we have the P go to 4 and the V go to 4, then we still end up having 16. And then here's another one, 2 times 8 is still going to end up being 16. So you can see that we can mess around with these numbers, but we're still going to end up having a constant. So Boyle's law, this is the formula that we need to learn. Boyle's law can be stated that P1 times V1 equals P2 times V2 when T temperature is constant. So how can we apply this? Well, breathing. So during inhalation, the lungs expand. So put your hands over your lungs and then breathe in. You can feel that your hands go out. So that shows you that your lungs are going to expand during inhalation. And because of that, the pressure in the lungs is going to decrease as air flows towards the lower pressure in the lungs. So here you can see that the rib cage expands as the rib muscles contract. As we're inhaling the air, the lungs are going to expand, the diaphragm, right? So the diaphragm contracts or moves down as we are inhaling. Now, as we are exhaling or during exhalation, the lung volume decreases, or the pressure in the lungs increases. So air flows from the higher pressure in the lungs to the outside. So you can see we're pushing this up, exhaling the air, and the rib cage is getting smaller as the rib muscles are going to relax. So how do we use this? Here is our handy dandy little step guide. So step 1, we're going to organize the data in a table of initial and final conditions. Step 2, we're going to rearrange those gas laws equations and solve for the unknown quantity. Step 3 is substituting the values into the gas law equation and then calculating. So let's do an example together. So Freon 12, which is CCl2F2, was used in refrigeration systems. What is the new volume of an 8.0 liter sample of Freon gas initially at 550 millimeters of mercury after the pressure is changed from 2,200 millimeters of mercury at a constant temperature in moles? Wow, that's a handful, right? Mouthful. All right, so let's organize. So what are we going to do? We are going to analyze the problems. Condition 1 is that the P1 is 550 millimeters mercury, V1 is 8. Conditions 2, we're changing the P to 2200 millimeters mercury, and we have to solve for V. The known is that the P, or pressure, is going to increase, and we have to predict that the volume is going to decrease, and again, temperatures and moles are going to remain constant. So let's rearrange the gas law equation to solve for the unknown quantity. So again, we have P1 over V1, and then we're going to take P2 from this side, take it over so that we can simplify so that volume 2 is equal to V1 times P1 over P2. So let's calculate. We have V2, therefore equals 8.0 liters times 550 over 2,200, and then the millimeters of mercury cancel out, and that gives us the V2 of 2.0 liters. All right, good job. So let's see. A sample of oxygen gas has a volume of 12 liters at 600 millimeters of mercury. What is the new pressure when the volume changes to 36 liters at a constant temperature and N number? All right, pause me, come back. All right, so again, first thing we're going to do is organize the data in a table of initial and final conditions. Okay, so you can see the temperatures and the moles are going to remain constant, and we're predicting that the P is going to decrease. So let's set it up, rearrange so that we can solve for P2, input the numbers, and we can see that the answer is A, or 200 millimeters of mercury. Okay, here's another one. For a cylinder containing helium gas, indicate whether the cylinder A or cylinder B represents the new volume for the following changes. Okay, and again, N and T are remaining constant. So pause me, think about it, come back. So what's going to happen is the pressure decreases in cylinder B, right, because the volume's getting bigger, where the pressure is going to increase in cylinder A because the volume's getting smaller. Okay, so if a sample of helium gas has a volume of 120 milliliters and the pressure of 850 millimeters of mercury, milliliters and millimeters of mercury, what is the new volume if the pressure is changed to 425 millimeters mercury with a constant T and N? Pause me and come back. So let's set it up. We're going to organize the data again in the table of initial and final conditions. Again, knowing that temperature and moles are going to remain constant. And then we're going to set it up so that we're going to solve for V2. You can see that when we do that, V2 is going to end up equaling 240 milliliters, and the answer is C. All right, good job. Last question. A sample of helium gas in a balloon has a volume of 6.4 liters at a pressure of 0.7 atm. At 1.4 atm, where T and N are both constant, it's the new volume represented by A, B, or C. Pause me, think about it, and come back. All right, so at a higher temperature, with T and N both being constant, the new volume is going to be represented by the smallest balloon, A. All right, great job, you guys.